It's been a while since we've done calculations with with the normal distribution, and so let's kind of remind ourselves how this goes. Okay, so problem one. Okay, suppose we have a normally distributed random variable x and has a mean of 45 and a standard deviation of 5. Calculate the probability that x is greater than 47. Okay, so we know that x itself is normally distributed. Okay, so what's the probability that x is greater than 47? Well, we take the z-score of everything. And this time we know our original random variable is normally distributed, so when we divide it, we can divide it just by the standard deviation. We don't need to take the standard error of the mean. Standard error of the mean we only do when we're taking a sample, and we're not taking a sample here. We take our z-score of everything. This is asking the probability that z is greater than 0.4. This is a tail, right? So 0.5 minus the table lookup for 0.4, and this is 0.3446. Problem 2. Okay, we have a random variable with an unknown distribution. It has a mean of 45 and a standard deviation of 5, but we're taking a sample of size 30, okay, our magic number. Calculate the probability that the sample mean of x will be greater than 47. Okay. Alright, so mean 45, okay, this standard deviation is equal to 5. We don't know what how this is distributed, but we take a sample of size 30, and so we know that the sample mean is normally distributed with a standard deviation of 45 and a standard deviation equal to the standard error of the mean, which turns out after our calculation to be 0.9. Okay, we ask, what is the probability that the sample mean is greater than 47? Well, we take the z-score of everything, but since we have the sample mean as our random variable, we have to use the standard deviation of the sample mean, the standard error of the mean, right, which is what we calculated here. And so we got 47 minus 45 over 0.9. This is 2.22. It's a tail, so it's a 0.5 minus the table lookup for 2.22, which is 0.4868, and so our answer is 0.132. Problem number 3. The tongue length of the southeast Kansas strip pit salamander is normally distributed with a mean of 7.2 centimeters and a standard deviation of 1.1 centimeters. What is the probability of catching a salamander with a tongue length between 5.0 and 6.1? So here we're not taking a sample, we're just going out and catching a salamander, and we want to know the probability that his tongue length is between that. And okay, we know that this tongue length of strip pit salamanders is normally distributed. Okay, the mean is 7.2. The standard deviation is 1.1. What's the probability that the tongue length is between 5 centimeters and 6.1? Take the z-score of our event, our Z is between -2 and -1. This is a thin event, right, because 0 is not between the two. And so we subtract. And the table lookup for 2 is 0.472. Table lookup for 1 is 0.3413. You do the math and you get a probability of 0.1359. Problem 4A. Okay. The tongue length of the strip pit salamander is normally distributed with the mean 7.2 and the standard deviation 1.1. Okay, a grad student samples 30 such tongues. Oh boy, what a magical summer that was. What is the probability that the mean of his sample will be between 5.0 and 6.1? Okay, the only difference here, we've taken a sample, right? Again, sample of size 30. This changes when we do the standard deviation of the sample mean. Taking a sample reduces it tremendously, right? To standard deviation 0.2. We start out, what's the probability that the average he gets is going to be between 5.0 and 6.1? Well, you take the z-score, and what happened, you get a weird event. The weird event is out on the thin end of the curve, right? You've got your normal curve, like, looks like this. Well, this is like out here where the curve is almost indistinguishable from the line, and so the probability is just, for all intents and purposes, 0. Okay, with the same information, what is the probability of a sample of 30 tongues? The mean of a sample of 30 tongues will be between 7.0 and 7.4. So we're taking it to a different part of the curve. And so in this case, okay, it's the same information, so it's normally distributed, mean 7.2. The standard deviation, the sample error, is the standard error of the mean is 0.20. What's the probability? X bar is between 7.0 and 7.4. We take the z-score of everything, and this gets us, z is between -1 and +1. We do the math on it, okay, and get a probability of 0.68. And so the difference between this and the previous one is we're in a different part of the curve here.